Next, we'll be looking into the temperature entropy diagram, or TS diagram as it is commonly called. So TS diagram is a thermodynamic plot between temperature and entropy. Okay, usually we have seen PV, PT, VT diagrams. So they are all thermodynamic properties. TS diagram is between temperature and entropy. As you have seen, they are also two thermodynamic properties. So in case of temperature, we use the absolute temperature scale, and in case of entropy, the unit is usually kilojoule per kilogram. Sorry, kilojoule per Kelvin. Okay, kilojoules come from the unit of heat, and Kelvin comes from the unit of temperature. Sometimes we may have specific entropy, then we'll have kilojoule per kilogram Kelvin. That's for specific entropy. If we have molar entropy, the kilogram will be replaced by mole, kilojoule per mole Kelvin. Okay. So what is the TS diagram? Okay, what is the area under the TS diagram? So we can, as T and S are both parameters or properties of a function, properties of a system, we can represent all things, or all processes that we had represented for PV diagram in terms of TS diagram too. So in case of PV diagram, we know that the area under the PV curve would represent the work done. Okay, PV is usually drawn for a closed system. So in case of closed system, the work done is represented by the area under the PV diagram for a single process, and in case of a cycle, the area inside the cycle, that cycle. So if we have a PV diagram, and this being an arbitrary process, the area inside this will be the work done by the cycle to the surrounding. Okay. In case of a TS diagram, so we have by definition of entropy, integral of A to B, delta Q by T, R is equal to delta S, or in the differential form, we have delta Q by T reversible is equal to TS, or delta Q is equal to TdS, where this is reversible. Or if I integrate it, I'll get integral A to B delta Q by T is equal to integral A to B T ds. So Q, that is the for a single process, that is from A to B, S T. If I look at so the area under the TS diagram. So if we look at the process from A to B, if you consider this is A, this is B, the area under this curve will give us the amount of heat transferred. So this can be positive or negative. So it depends on the cycle. Here, if I'm going from A to B, this has a net positive temperature change. Usually, this is associated with the positive heat transfer. Okay, that's 0. If I have gone from point B to point A, this would have resulted in heat rejection. Should have given me a negative number. So this is what we have in a TS diagram.